All right, welcome everyone. In this video, we're going to be looking at the roots of quadratic equations. In our previous class, we talked about quadratic equations, polynomials, how to solve quadratic equations. And so now we're going to look at the roots of a quadratic equation. Okay, so if we are given a quadratic equation, say ax squared, we know this is a general form, ax squared plus c equal to 0. And so we say that the root of a quadratic equation, which is also called the solution of the quadratic equation, or you also call it the zero of the equation or zeros of the equation, is actually any number. For example, if we say t, for instance, or k, let me say k. So we can say that k is a root of this equation if by the time we substitute x as k in this equation, we will get 0. So for instance, what that means is that if k is a root of this equation, then it implies that a times k squared plus bk plus c is going to give us 0. So we are saying that if k is a root, then x is equal to k. Okay, so we have some examples to see this. For instance, if we have, let's say, 3x squared minus 4x minus 15 equal to 0. So you can say that that a number, say 3, x equal to 3 is a root of this quadratic equation, and you can see that that is true. If you substitute this x as 3 into this equation, we are going to get 0, and we can quickly do that. So if you put x as 3, here you have 3 squared minus 4 into 3 minus 15, and of course you can see that this is equal to, this is going to give us the square of 3 is 9 times 3 is 27. We have 27 minus 12 minus 15. And of course, if you evaluate this, you are going to get 0. So 3 is actually a solution, is a root to this equation. And you can also check that x equal to minus 5 over 3 is also a solution, is also a root of this quadratic equation. The next thing we're going to look at is the nature of roots. So there are 3 different categories of roots that you can obtain from any quadratic equation you are given. And this is dependent on what we call the discriminant of a quadratic equation. So, and what is this discriminant? You recall that by formula method, which you have learned, that x, which is a variable, is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what does that mean? So you would see that from this equation here, that particular expression under the square root, that is your b squared minus 4ac, is usually called the discriminant. The discriminant of the equation. So we call it the discriminant of the quadratic equation. That is this. And sometimes we represent it with d. Okay, so we can call this d. We can say that this is equal to d. Okay, so whenever we want to know the nature of the root of any given quadratic equation, we will go to this particular expression under the square root. And so when you make the substitution, you look for the a of that equation, the b and the c. Substitute into this formula. The value you will get will tell you what the nature of that quadratic equation is. And so we have 3 categories in this. And so we are going to quickly look at these 3 categories. So the first category we are going to see now, when you have a quadratic equation, it can either have real and unequal roots. It can either have real and unequal roots. And when does this happen? Now, this type of root is obtained in an equation that has in an equation where your d, which is a discriminant, is positive. That is when it is greater than 0. You are going to obtain a real and unequal root. Okay, all right. So we said that the nature of quadratic roots: one, you can have real and unequal roots. And for us to have real and unequal roots, we are saying that the discriminant has to be greater than 0. That means if we take the a, b, c of that quadratic equation and substitute into this formula, we should get a value greater than 0. An example is if you have something like x squared plus 5x minus 6 equal to 0. Of course, you can see that this is going to give us real and unequal roots, because here our a is 1. That means d is going to be, our b is 5. Okay, so our b is 5. So you're going to have 5 squared minus 4 times a is 1 times c is minus 6. And so you are going to get of course, if this multiplies, you're going to have minus 24, sorry, plus 24 plus 25, which is going to give us 49. And of course, 49 is greater than 0. Okay, so now when you have this, remember that also that whenever you have an equation, we also would want to see how the equation is going to look graphically. And so from the roots of the equation, you will be able to determine how the graph of the equation is going to look. So there are two things you need. Number one, the nature of the root. Then number two, the nature of your a. So if you have ax squared plus bx plus c equal to 0, and this one is a separate condition, and your a is greater than 0, then meanwhile note that whenever you draw the graph of a quadratic equation, is always a curve. So it is either you have a u curve or an n curve. You can either have something like this, or you can, for you to have a u curve, then your a must be greater than 0. Now for if you now have an n curve, then an n curve, then it means your a is less than 0. Meaning if you have a negative coefficient of x squared, then you're going to have an n curve. Okay, so now having seen all of this, now for the type of root a that we got, we are then saying that the curve is going to be exactly like this. So it's going to cut the x-axis at 2 points. That's to show you that they are real and distinct. That's unequal, real and distinct roots. And or it can be like this, depending on the nature of your a. Okay, so these two will now determine whether it will be n or a u curve. So, but if it satisfies that first nature, which is real and distinct, then it can either be any of these two. All right, so we quickly will go to the second type or second nature. The second nature is when you have real roots. Under what condition will you have this? That's the condition that your d is equal to 0. So when the discriminant of a quadratic equation is equal to 0, it will always produce a real and equal root. Okay, and what about the nature of the graph? This is how it's going to look. I'm going to use just a small graph now. So now if they are real and equal, it is just going to touch the x-axis at a point, something like this. So that's to show that the both roots of the quadratic equation, is just at one point here. Okay, so, and remember that for this, your a is greater than 0, and then the other way round, if it is this way, then your a is less than 0. Always remember that this is your x-axis and this is your y-axis. Okay, and an example for this, we can get one example for this: x squared minus 4x plus 4 equal to 0. I think this is going to give us that kind of equation. We can check that. We can see you have b squared minus 4ac. Our b is minus 4. Minus 4 squared is 16. Minus 4 times a is 1 times 4. This is going to give you 16 minus 16, which is equal to 0. So this is an example, a typical example of a quadratic equation having a real and equal root. And of course, if you solve this, you are going to get x to be equal to 2. Okay, 2 twice, that's 2. Okay, so that's the second nature. Now what about the third? The third nature is when we have what we call complex roots. Okay, complex roots. So what condition gives us complex roots? For us to have complex roots, the discriminant must be less than 0. So these are the three conditions: when d is greater than 0, when d is equal to 0, and when d is less than 0. For each of these cases, you are going to have different nature of a root. Okay, so remember that complex root means that each of the roots is going to contain a complex number. So root 1 is going to be of this nature, something like p plus qi, and root 2 is going to be something like a p minus qi, where p and q are real numbers. But your I, of course, you remember when we talked about complex numbers, our I squared is equal to -1. Okay, so now what is the nature of this graphically? So when you have your graph, is going to look this way. When it is when a is greater than 0, the graph is not going to touch the x-axis at all. Remember that the x-axis represents the real line where you have real numbers, but since this is just complex numbers, so it's not going to touch the x-axis at all. So it's going to be something like this. And then if it is when a is less than 0, it's going to be something of this nature. Okay, so it's not going to touch the x-axis at all. So this is these are the three categories or nature of quadratic roots that we have, and we'll quickly look at some problems or questions that you can see, from these concepts that we have studied now. All right, so here we have a problem present here. It says, for what value or range of values of lambda will the graph of the equation this not touch the x-axis at all? Okay, so first of all, we have to interpret what we have. For the graph of a quadratic equation not to touch the x-axis, it means that you have a complex root. Okay, so, and then we know the condition for complex root. So we begin by saying, for the graph not to touch the x-axis, it means that b squared minus 4ac must be less than 0. And so for this to happen, what do we then do? So we are now going to look for the value of lambda, which is what they are asking for. And so from this equation now, we'll find our a, b, and c. And so from here, our a is equal to, and our c is equal to 1. So we are going to make substitution into this formula and see what we have. So if we put lambda plus 2 here, all squared minus 4 into a is now 3 lambda plus 1, and then our c is equal to 1. Okay, and now we are saying that this must be less than 0. Okay, so when you have this, if you open up this bracket, you are going to have lambda squared plus 4 lambda plus 4. Now this is going to give us minus 12 lambda minus 4 is less than 0. Okay, so we collect like terms. We have lambda squared minus 8 lambda, and this is equal to 0. Of course, this will take away this, so you will now have less than 0. So we try to simplify what we have by factorizing lambda. So we are going to have that lambda into lambda minus 8 is less than 0. Okay, and so by okay, now by definition, for a product, let me write that here. Okay, let me use this. For a product AB to be less than 0, now two things are involved. It is either A is less than 0, no, yeah, either A is less than 0 and B is greater than 0, or A is greater than 0 and B is less than 0. That is, if you have a product of two numbers, for it to give you a negative number, one of it must be negative. If both of them are negative, then you will not have a negative number. And if both of them are positive, you will never have a negative. For you to have a negative, one must be negative. And if A is less than 0, that's negative, and this is greater, then if you multiply the two, you will have something less than 0. And the same is applicable here. And that's what we are going to bring here. So for our lambda times lambda minus 8 to be less than 0, it implies that it is either lambda is less than 0 or lambda minus 8 lambda is less than 0 and lambda minus 8 is greater than 0, or that lambda is greater than 0 and lambda minus 8 is, in this case, less than 0. Okay, and now when you have this situation, what are you going to get? Okay, so we now try to check these the ranges that we have here, to see which one is going to be true. Okay, so can we combine these two? If of course, let's finish this from here now. The last condition here means that lambda is greater than 8, and the last condition here means that lambda is less than 8. Now, can we combine the first one? Lambda is less than 0 and the same lambda is greater than 0. Is greater than 8. You see that is impossible. Okay, this is a contradiction. Lambda cannot be less than 0 and at the same time greater than 8. Okay, so let's check this. Lambda is greater than 0, lambda is less than 8. This one makes sense. And you can join the two of them together. This means that 0 is less than lambda and lambda is greater than 8. So joining these two together, you have gotten the required range of values that will make this equation give you a graph where it will not touch the x-axis at all. So that means lambda has to be greater than 0 and strictly less than 8 to give that. Okay, and that is the solution to this problem. Okay, all right, so we'll do a second example on that also. Now, this question says that we should find the least value. Please take note of that. It says we should find the least value of t for which the equation this is going to have is going to have real roots, and that's what we want to look at. Okay, so now remember that the beginning of all of this is the definition. That's the nature of these roots. And so for what condition will a quadratic equation have real roots? Now look at this. It just says real roots. It didn't say whether it is real unequal or real equal, meaning two of them are captured here. And for a quadratic equation to have real roots, it means that b squared minus 4ac must be greater or equal to 0. If it has real unequal, that's greater. If it has real equal, that's equal to 0. Okay, so the two conditions are captured in this one. Okay, and so for us to now find what we are looking for, we will need to substitute a, b, and c into this equation. And from here, we have that our a is simply equal to t minus 1 So we're going to have, okay, 2 raised to power 2 minus 4 into a, which is t minus 1, and then times c, which is also t minus 1, and this must be greater or equal to 0. And if you watch what we have here, you will see that this is the same thing as 2 raised to power 2 minus, okay, this is going to give us 2 into t minus 1 all squared. Watch carefully what I am doing now. Of course, you can see this multiplying this will give you t minus 1 squared, and I can change 4 to 2 squared, and so if you open this bracket, of course you will get back this. Okay, and why am I doing that? I did that so that I will be able to apply the law or the principle of difference of 2 squares. You can see we have difference of 2 squares here. That doesn't mean that if you open up this bracket you won't get the same answer, but this is just going to make it shorter for us. And so by difference of 2 squares, I am going to have 2 brackets now. That's 2 plus 2 into bracket t minus 1, and then into another bracket, and in the second bracket I'm now going to have 2 minus 2 into bracket t minus 1. Of course, remember that the principle of difference of 2 squares says that x squared minus y squared is equal to x plus y into x minus y. Okay, that's what I applied here. All right. Okay, so from here now it is easy for us to simplify what we have here, and that's going, remember that this is greater or equal to 0, and that's going to give us, if you open up this bracket, you have 2t minus 2, and that minus 2 will cancel this plus 2, so we are going to have only 2t left here, and that's going to multiply. In this case, you are going to have, this is going to give us minus 2t plus 2, and so that plus 2 will add here to give us 4 minus 2t. Okay, and that's greater or equal to 0. Okay, and we are going to also apply the same thing we used here. And so what's that going to give us? So from here now, it is either our 2t. Okay, remember, like what I said in the earlier case, this is greater or equal to 0. For us to have something greater or equal to 0, then the two are going to be the same sign. It's either both of them are less than 0 or both of them are greater than 0. If any of them is less than 0 and the other is greater, you are going to get a negative sign. So since we want a positive or equal to 0, so that means our 2t must be greater or equal to 0, and 4 minus 2t must also be the same. Okay, and in that case, or it is also either that 2t is less than or equal to 0 and 4 minus 2t is also less. So when the two of them are less, that's negative negative. If you multiply them, you get positive. When the two of them are greater, that's positive positive. If you multiply them, it will still be positive. Okay, so from here we will try to simplify what we have. So if we simplify the first one, we're going to get that t is greater or equal to 0, and from here 2t will go over to this side, and when you divide by 2, you will get that t is less than or equal to 2. And then we go to the second one, or in this case t is going to be less than or equal to 0, and if you do the same here, you are going to get that t is greater or equal to 2. So let's check the two conditions and know which one is true and which one is not true. This is saying that t is greater or equal to 0 and t is less than or equal to 2. Okay, this makes sense a little. Let's check the second one. T is less than or equal to 0 and t is greater than 2. That doesn't make sense. T can't be less than 0 and be greater than 2. It is not possible. So that means this condition, this range will not work. So let's now bring this one together. This is going to give us 0 is less than or equal to t, and t is less than or equal to 2. So first of all, this is the range, assuming they asked us for range. That if you go back to the question, they said they are interested in the least value of t, and if you come back here, you will see that the least value of t in this range here is t equal to 0, and that is the answer that we are required to produce. So t equal to 0 is the least value that will make that equation given to us to have a real root. Okay, and that's all we have for this the concept of roots of quadratic equation, the nature of roots of quadratic equations, and problems involving roots of quadratic equation. And we will end it here for this class. Please kindly subscribe to our YouTube channel, like, comment, and share our videos, and we will see you in our next video. Thanks for watching. Bye.